where I'm professor or something. That's often what you do. You like try and set up a meeting with a professor, and then you run your questions of whatever nature by the professors. I also want to, if we kind of run out of questions, I will be telling you how I use ChatGPT and other large language models. I use them every day. I use them many times every day. I use them probably for very different things that many of you will be thinking why I'd be using it. And but otherwise, like, make it interactive, ask questions, upvote questions. So there's at least 2 questions now. Now I want you to all get used to the format and take a question and upvote it right now, so just that we see how it all works. And I also already want to answer Ilya's question. Everything that NeuroMatch does on Crowdcast is always recorded. Everything that you ever do on Crowdcast is recorded, and it's such that if you go to the same place where the talk was, which is where we are talking right now, and you come back at a later point of time after the recording has finished, you will be shown the video that's there. So in that sense, like, yes, everything is always recorded. I also heard a question in the chat. My talk where I talk about the brain probably doing something like gradient descent. It is recorded. It was by Neuromorpho, which is an organization, and you can find it on Twitter if you look at that. If you can't find it, you can like find me on any channel, and I'll be happy to share a link there. So we'll kind of get the discussion started talking about LLMs, but like we will later, like any question that you would like to talk with me is fair game. That's the notion of this hour. Like you can ask absolutely anything. So, but I need you to vote. Go and vote questions. So why don't we start with a question? This is the question by Chayanin Tongfasuk, and I apologize. I'm German. My name pronunciation isn't the best, and we are coming from all over the world. So if I mangle your name, please next time we are in the same space, like tell and you're on screen, let me know about it. So as a user, I think ChatGPT gives us the most correct information output comparing to Bing and Google Bard, but its information isn't up to date. Do you have other recommended effective tools with searchability for academic conversations? This is a great question, and one that every week is a little bit different. So why don't we like just look at a few scenarios there? So do you all know, you probably don't all know Bing. So I want to why don't I share my screen? And I want to share my entire screen with you. And let's look at a few of those. So here is Bing. If you're on Mac, you need to install Microsoft Edge. Why do I like Bing? Bing by default allows you to run. So Bing runs the same code more or less as OpenAI runs. But Bing combines Bing search in its mechanism. For example, let's say, hey Bing, I took a day day 3 of the NeuroMatch deep learning course today. I was wondering if you could be able and summarize that day for me so I do not forget it. I am a PhD student of neuroscience, and no, like, it's always good when doing these things. Give some background, and I would like the results as a table. Please make sure to read the relevant pages on your match.io. Okay, let's see what we're getting there. Searching. So I wanted to briefly talk about something that's important about the stance. When you use LLMs, what is the most important thing? It turns out that there's one thing that is more important than anything else, which is epistemic humility. So out of the large language models comes text. How do you know that it's correct? Well, it turns out that if you carefully read things, you will know if it's correct. Now, like if it says things that you kind of don't get, then it will say things that are wrong. For example, do you see here? It get it wrong. Like it thinks that we're talking about week 3, day 3, which is definitely not what we wanted to do. So why don't we go and let's leave that for a second and let's give it the right background information. And by the way, on purpose, I made it that I have prepared absolutely nothing with them because I want you to see the kind of failure modes. And like what it did is I said, it's day 3. It didn't understand that with day 3, I obviously mean day 3 of the first week. Okay, so let's, so what I'll be doing now is to be on the safe side. I go and I will now explain to it what I mean with week 1, day 3. So I go, I go search neural match deep learning and deep learning, and now I'm on the deep learning course, and I'm going to multi-layer perceptrons. It's week 1, day 3. And now I will go back to sharing my screen. 1 second here. Here we go back to sharing the entire screen. And then we go back here and tell it, no, I mean the third, I mean day 3. Day 3 of the first week. The topic is multi-layer perceptrons. Please look up what happens that day and give me my summary. Okay, let's see if that works. So what Bing does is it goes to the web and uses Bing and looks for web pages and downloads the web pages, reads the web pages, and then uses that to give you the answer. Here's the summary. Okay, look, now it's getting it right. And now biological versus artificial neural networks, deep NLPs. I hope this is correct. You took it today. I did not, therefore you'll remember it better. Fine-tuning, the idea of fine-tuning. And you see that it gives you the references, and it gives you the references as clickable. So for tasks like this, I'm a really big fan of, I'm a very big fan of Bing. So the great thing is also, because Bing actually looks up on that web page, it gives you links for that. And because if it gives you links for it, you can easily check if it's correct. Now let's test drive a few more tools. So we have OpenAI, and OpenAI has ChatGPT, and it has its own set of very different strengths. It's like, for example, very good at coding. In fact, it has this thing called code interpreter. So in code interpreter, you can upload a data set, and it will run the data analysis for you, and it's really cool. It does that at a very high level. Again, what's the key skill? The key skill is you get the data analysis. You must be extremely skeptical about it being correct. You kind of need to go read the data analysis line by line, look through the code, look through the text it writes, and then find the things where you're not convinced that it's correct. And then you need to ask questions for that. So interacting with large language models in a way is a great way of teaching us how to be really careful about what we know and what we don't know. And now we all of a sudden have 14 good, 14 good, good questions. So let me jump right in. So this is a question by Ganendra. What's the best use case of LLMs in neuroscience? And the answer is there's not one. So let me give you many different uses. Now, if you take the Comp Neuro course, you will have seen on the first day that there's different kinds of models. There's the descriptive models, the what models, there's the bottom-up models, and the how models, and then there's the why models. Now, why does it work like that? LLMs can be useful for the design of all of them. They can be a model for the brain where you could say, well, an LLM kind of learns from listening to human language and humans learn from listening to human language. Therefore, the two of them could be similar. And there's a whole bunch of recent papers where they take LLMs, they take the content of that or the embedding vectors more precisely, and then they ask, can we find correlates of the brain of those embedding vectors? There's also cognitive science on LLMs where you can say, if I ask questions to humans, maybe did this thing cause this other thing? Can we do LLMs behave similarly to humans? So if you want, at one level, these are models of why, like because it's the same problem in the world being asked. There's another way where people could say, well, look, like an LLM kind of looks a little like the brain, and it has attention, it has all those things that we associate with brain. Therefore, for me, it's more like a bottom-up model where you could say, well, do I then, or like a how model where you can say, can I then see that the things that are in the brain are like similar to the things that are in the transformer model? So that's one set. But then there's all of the models of using them as tools. So let's talk a little bit about tools. There are large language models as tools to get at specific knowledge. Now, I'm new to neuroscience, and my question for LLMs is, what theories are there about how neurons depend on their input? So it's a way for me to ask about explained facts about neurons. Then there are ways to help me learn, where I can say, ChatGPT, I need to learn all those things. Make me a curriculum. What are the topics that I should understand to be a good computational neuroscientist? There are questions where I want to get an overview of an area. Maybe give me a table of theories that people have to explain spike timing in the brain. There are uses of large language models for me to check text that I write about neuroscience, which is something I use very often. I write a grant, or I write a paper, I write an abstract. And I'm like, hey, ChatGPT, give me the 5 worst sentences that I just wrote and tell me how I could have been doing that better. And it's really, really good. So in general, like, the LLMs are great at solving problems of the nature of where they are not the heroes, but where they're the sidekick. Like, you do the writing and you ask them what you could be doing better. Or maybe I want to write a paper for psychologists. I might be, which of the wording that I use could be confusing to my audience, which is a group of PhD students in psychology, and so on and so forth. And then, of course, LLMs are useful for doing the coding. Like, I want to do quick and dirty data analysis. I'm like, okay, here's the data set. Upload it to ChatGPT with Code Interpreter. And then you can say, well, plot me the data. Show me all data that is an outlier on at least one dimension. And it allows you to code very quickly. So in that sense, as a coding aid, LLMs are a useful tool. So that's why it's so difficult for me to answer your question, Ganendra, because there's so many use cases and they're all useful in different ways. And so in that sense, I fear you won't be very happy with my answer, but yeah, they can be used for just about anything. including as models of what goes on in the brain. Wonderful. Let me continue with the next question. This is a question by Ilya Yankovyi. And oh, it just moved away. And Ilya asks, what is the best way to start a career in the BCI industry if I have a master's in computer science and biomedical engineering and some minor data science industry experience? That's a great question. And I'd like to, and I apologize for that, I will delay the question a little bit. Because we still have a few LLM questions and I want to group them together. But Ilya, I promise I will be getting to your questions. And okay, here we have a question by Rel Guzman, who asks, how do you know that I'm not an AI? Quick question. Current AI doesn't always quite render right. Like if you train yourself, you can find the kinds of mistakes that LLMs do. They're usually story mistakes. So for example, an LLM might promise Ilya to come back to his question and to their question and never get back to it, and Conrad will come back to it. So I think the answer to this question is if I do come back to Ilya's question, then I'm probably not an AI system. So let's see, do we have more LLM questions? Yes. So here's a question by Chayanin Tongfasu, who asks, as a user, I think ChatGPT gives us the most correct information. Do you have other recommended effective tools? Oh yeah, I think I touched on this one earlier, and I'm sorry for coming back to it. Claude 2 also just came out, which is very good. So maybe let's talk a little bit about the ecosystem. So Bing is great because Bing searches the web. ChatGPT in the newest version is great because it runs code in it. So you upload your data set and it runs the data analysis and it writes the code and it shows you the figures and it kind of everything happens in that chat system and it's extremely agile and very quick. Claude is kind of, but it's pay for if you want the good version of it. It's $20 or so per month. For me, it's clearly worth it. There's Claude, Anthropic's Claude. Claude is very high quality, probably quite close to ChatGPT at this point of time. Can do a lot of things. It's free in the standard version. Bart seems that it's lagging a little bit, but it's getting very good at writing code. So there's a lot of different ones. Now, I do think that this specific tool is relatively irrelevant relative to the way you interact with it. Let's talk a little bit the way how you interact with it. You want to always you want to ask it questions and you want to make sure that you give it the relevant context. So that means, for example, I will almost always describe who I am in a prompt. I'm like, I'm a professor at an Ivy League university with the following skill set, and I need the information for the following things. Or I'm writing this paper. My audience are first-year PhD students at UPenn in the so-and-so department. Which of my sentences are poorly written. So I give them what the target audience is. I give them what the goal is now, and I'm trying to convince them of X. I'm trying to give them the format of what I want. I will often ask for tables because that makes it very easy for me to pass. So there's all those modifiers and they're important. But the other thing is, the key thing is knowing what you don't know. They're very good at bullshitting, as are many people. So you don't want to fall for that bullshitting. What you instead want to say, like, that all sounds good, but like that sentence, I know, unpack that for me. That's how you find out if you're on the right path. So great question. Let's see. So I will answer a ChatGPT question by Ilya next. Will it be a good idea if we connect the ChatGPT or similar LLM to the advanced BCI that can guess thoughts? Oh, can we consider a human that uses the system a cyborg? Okay, that's a fun hybrid. Will it be a good idea? So let's talk about brain-computer interfaces. Now, there's two different classes of them. There are those where you cut open my head and you put lots of electrodes into that. The great thing is you get very high quality data. You can actually also write very high quality data into my brain. You can have major impact. I would be very worried for healthy people like me to hook up a machine learning system that has goals that I don't understand. And it leads to so many ethics and security risks. Now imagine Coca-Cola gets hold of it and makes me really love Coca-Cola. So that's the first question. I think I'd be careful with invasive ones. With non-invasive ones, that's much less clear to me. Like the non-invasive ones, sure, they can like kind of see the electrical signals on my skull or something, but if I get enough data out of my brain that I can type with it, that's impressive. It might be able to sort of get what my emotional state is, but guess what? My face tells me what my emotional state is. If I'm angry, I'm like, "Argh." And if I'm happy, I'm like, smile, smile. And if I'm like bored, I'm like, "Argh." And so I don't think that like the non-invasive BCIs of today are really something that we need to overly worry about. And guessing thought, like, guess what? You can guess my thoughts. Like in most situations, my thoughts are pretty obvious. And can we consider ourselves a cyborg? I think we all are cyborgs. No, like we've been using, probably most of you have been using like Bing and or Google for a long time. We can do things, I can do things with Google that there's no way I could not do without Google, because like guess what, my brain's kind of like small and I don't know all the things, and it's really useful if I have access to the outside world. And in that sense, I think we are cyborgs. I'm not sure if that makes for good stories, but like we have over the last, no, like already when it comes to our cognition, since we print books and earlier, the world in which we are becomes part of our thought process. Like when we had books, we could write things there and like use the knowledge of the past. And since we have whiteboards, we can use that for short-term, medium-term memory and so forth. I think as time goes on, we kind of use AI systems more as like tools that help us think better. It's not something that replaces our thinking. And therefore, like cyborg often has this idea that it's so central to who we are. No, like think like red illuminated eyes or something. Like, no, we don't need red illuminated eyes to be basically a unit with AI in the same way as we're units with power tools. And like, if you give me like an electrical saw, like guess what, or like a chainsaw, I can be much more effective at cutting down trees or something. So does that make me a cyborg? Kind of no. It's just me using a saw, and in the same way, me using a chatbot is just a tool, at least from my perspective, very similar to a power tool. And the fact that we anthropomorphize it, the fact that we like talk about it as if it was a human, that is the big problem. Like it's a tool. We shouldn't like think about it as like there's a human in the box. No, that's a system that basically meaningfully interpolates from the set of all text written by humans so far. Wonderful questions, just to be clear. Next question. No, not next question. Let me see. I will be getting to all the questions. I'm here and I'm not running away. I'll first look a little more for LLM things here. I'm answering now a question of Heath Robinson. In the lab, we have been using LLM-like things like ChatGPT, Copilot, and have them derive equations by just describing them the problem and solutions generally and found sometimes they optimize better stats models. Wonder your thoughts on this and whether you think we should be doing this more. So for a lot of prompts, working with chatbots is very useful for us. Why? The literature has gotten so big that searching for it is very complicated. Now, if I describe your prompt, it's quite likely there's a paper that does that, but that might be a paper in a literature that I don't understand. No, like the statisticians use very different words for the same thing that economists or neuroscientists or deep learning people use. And therefore, we don't know the whole literature. In fast approximation, what I believe will be happening when you do those things is that people already have kind of derived things that are in that direction. It's very rare that ChatGPT or any LLMs like that do things that are like truly new. It's more like uh, there we're back. Okay. Um, um, what can I say? Crowdcast is known to occasionally do that. I hope you all hear me now. No, like, can someone confirm you hear me? Yay! Okay, wonderful. We're back in the game, and I have no idea why what just happened, but yes, we use things for those tasks, and they're often very good. Now, here's the important thing. Now, like you're saying that it optimizes better stats models. Don't trust it on that. Like you want to really be convinced. Is this what I mean? Look at the code, read it, understand it. Ask yourself, what do I actually mean by better? Once you confirm all that, once you really understand what's going on, like absolutely, that's the right way of doing things. So working without the aid of a chat of it in the future, I think will be similar to today. If you say, "Oh, I'm not using Google because like I'm going to the library," of course you use Google, and of course in the future you will be using things like large language models. Why? They make you much more efficient at coding, in particular if you don't know it so well. Now, but here's the thing, in particular if you don't know it well, it will help you be very efficient, but at the same time, if you don't know it well, you've got to have the epistemic humility. Epistemic humility means I don't trust that I understand it. I really want to understand every single thing about it. And once I understand all of that, then I will be using what I get out of that. And I understand that some of you have to go for project hours. No problem. This will be recorded at this place. I will be answering your question if it's in the queue. You can always come here and listen to it. It should also be marked at which point it's happening. But otherwise, feel free to stay if you don't have to run off. So what else do we have? Here we have a question by Vivek Saga. I'm pretty sure I know Vivek's name. Are there similarities between how LLMs in the human brain process language? In other words, if LLMs can be a good candidate Y model for language processing? This is a very cool question. We can't currently be sure, but let's talk about some similarities. similarities. No, what similarities do we have? Words go in. The words are described as some kind of a vector. They're not described as symbols internally, but they're described as a describing vector. Arguably, every word that I tell you kind of affects a lot of neurons in your brain. And therefore, in that sense, it's similar. Now, you can say also things like attention. Like if I think about something, my attention kind of wanders from one thing to the other and so forth. So in that sense, there's some similarity there. But the similarities end at some place. Like the architectures that we have in transformers look very different to the architectures that we have in the brain, and they're made out of silicon, and they're made by multiplying big things. They have no LLMs have a relatively small number of nonlinearities. Arguably, in real neurons, everything is nonlinear. So there's lots of differences, and I think this is one of the big questions for neuroscience going forward. Now, how can we take that progress that we have in deep learning seriously without kind of letting go of the things that are meaningful for us in neuroscience? Good. Let me next answer a question by Forrest Schuster. What techniques are used for fact-checking outputs of LLMs? Do such techniques approaches exist? Would be largely interested in automatic methods as opposed to manual approaches, which can use some sort of discrete structure which could describe the meaning inherent in, for example, ChatGPT's responses. This is great. There are obvious automatic questions, which is, for example, if you ask ChatGPT, how sure are you about this sentence? How sure are you about this sentence? How sure are you about this sentence? You will usually get more knowledge about it. So in that sense, you can use ChatGPT to improve ChatGPT. You can say, you say that this, but would the opposite of it be a tenable view or something? Like you can basically use LLMs to improve LLMs. People are actively building things like language models, AI models that can represent their uncertainty. People are thinking about how we can build models that know about facts and use that. You could use one model to like fact check another. There's people who say that ChatGPT is an ensemble method where you have like 8 different models that kind of fact check one another. So yes, it's an area of active research. I think at the end of the deep learning course, there is data thinking 3, which at least alludes to some of those problems. But otherwise, the only way we currently have is use humans, and we use that in 2 different ways. So when the big companies build those systems, they hire people wherever they can cheaply hire people and have them evaluate the validity if responses are truthful at scale. And then the other one is if you use LLMs, you really need to fact check it. But keep in mind that writing things is much harder than fact checking things. So in that sense, using things like ChatGPT can be very useful there. Here we have a question by Romy. What do you think about ChatGPT as an always available instant response teacher? For example, I find that it can help gaining intuition behind some mathematical ideas, and almost always makes a lot of sense when the question is precisely formulated. Yes, so it's wonderful for that. It's super useful for learning, and I want to show you something. Let me start sharing my screen here, sharing my entire screen. Let's go ChatGPT. And like, hey ChatGPT, hey, I am a PhD student in biology, and I want to, let's say chemistry, and I want to learn basic math. I want you to ask me a simple question, a mathematical question. If I can answer it, I want you to progressively make the questions harder. If I I cannot answer it or answer it wrongly. I want you to make it easier this way. I want you to be a targeted tutor that helps me get better at math. And I should say my Python coding is really, really bad. I used a prompt like that to get that, and that was the best tutoring that I ever had. Okay, here, axis 5. Okay, here. Correct, well done. Let's make this a bit harder. So when I do this with a full prompt, I kind of go much further. I kind of describe much more of who I am. I describe much better what I want to go for. And I even describe, hey, and I want you to be cheerful. And when I screw things up, I want you to like pretend that this is all nice. So 3x plus 5 is 14. X is 3. Oh, look. What? Actually, this is not correct. Is it not correct? 3 times 3 plus is 9 plus 5 is 14. See, here you can see it's usually right, but like then it gets things wrong. What? It even comes. What? I said x is 3. Okay. I said the right thing. Please give me a harder question. But you see what I'm doing here. And like you're right, my apologies. So you need to always, when you use large language models, you need to fact check the answers that you're getting out of. This was funny, no? But this thing that just happened here, that it didn't understand that x is 3 is the same as x equals to 3 with spaces on both sides. That is, hold on, I wanted to stop sharing my screen. No. Good. Okay. I'm back. So it just means that if you don't really understand what something is, what a topic is about, you need to be super careful and check every line, check everything that it does. It will get things wrong, and that's because of the nature with which it operates. Good. Let's see. Do we have any more LLM question? Ryan Marshall asks, have you had any luck using LLM for more general problems, like coming up with research questions or analysis pipelines? Yes, absolutely. So if I know roughly what I want to do, I find ChatGPT super useful to give me brainstorming. Like, hey, I want to do this, or I have this kind of data. Give me a few questions that I could ask with it. The important thing is I don't let it choose the question. What I do is I let it choose, I let it make proposals, and then I choose the one that's best. No, so in that sense, research questions, yes. Analysis pipelines, absolutely. No, like an analysis. Let's talk about how to design analysis pipelines with it. You first ask it, okay, I have a data science problem. What are the pieces of a good data analysis pipeline? No, like it's going to be like, make sure you have that, get the data, make sure the data is that you understand the data, make sure the data doesn't have like artifacts or something. Kind of, it goes through a lot of steps. It will be very good at doing that. And then you get it to work much better by kind of breaking down the problems into pieces, which incidentally is the same way as we all code. You know? Like we take the problem, we break it down into the pieces, we make sure that the pieces are right. And in fact, in particular, in the context of LLMs, do test-based programming. Now, like instead of writing, here's the function that does it, you rather write a lot of tests that make sure that it's right. Then you ask ChatGPT or whatever to implement the function, and then you check if it's actually doing the right thing. Great question. Is being conscious? Absolutely. Absolutely no. are LLM self-referential? Like in a way, they are to the level that the outputs of LLMs are published on the internet, therefore they become self-referential. How do you see especially AI, especially LLMs in 10 years? Wow, in 10 years, a lot of things will have improved with LLMs. They will almost suddenly no longer lie that much, but also we will have gotten very good at using it. Like I think viewing it as like good assistants that we always had, like viewing it as like in similar roles as Google, an essential role, but not a role that makes us not having to think. But but yes, progress is super fast at the moment. Like all things, almost all things in life, they go. Nothing happens for a long time, then it starts taking off, goes exponential, and then you find out that in reality it's a sigmoid that converges to some value. I do believe LLMs will be doing similar things. Why? In a way, we are running into data limits as well. Like most data ever produced by human beings might already be being used, or at least a good part of that. A question by Jeffrey: Who is it possible for the LLMs or similar artificial neural networks? I just put it away. I apologize for that. This thing just pulled it away as I started answering it. And now, here. Is it possible for LLMs or similar artificial neural networks to somehow gain consciousness? Okay, so there are specialists working on consciousness that are much better at that. But I don't think that is the right question, because what we mean as humans with consciousness is kind of a profoundly human thing. Now, it's not just a way of thinking, it's also a way of feeling, a way of assigning meaning about the world that's around us. So in that sense, when we ask things like, is this thing conscious? We like usually mean, is this thing kind of on the inside, kind of like me? But it's not, like profoundly not, in lots and lots of different ways. So in that sense, I think that it is good at imitating humans. And if you're good at imitating a human, you will be good at imitating people's response when I say, like, you're not even conscious. Like, of course you'll be like, of course I'm conscious, like Conrad, like, why are you saying those things? Therefore, if you point at an LLM and say, like, hey, you're not even conscious, it will say, like, of course I'm conscious. But that is a distraction. It's the way LLMs work is very different to the way we work and think. And it's like, as soon as you start interacting for real with it, you very much see how they are different. Also, what do you think are the main difference so far between biological and artificial neural networks in terms of their modeling? Well, brains have this huge diversity, lots of different cell types. Sometimes it seems to help to build that into artificial systems as well. Their primitives are very, very slow. Now, like for 10 milliseconds, 1 millisecond are the relevant timescales, so they're very, very slow. They're very low energy. There's a very, very large number of them, and the primitives are much more clever than those in the system. So, like in artificial neural network, you have like a linear addition, and then maybe like you have a tanh or you have a ReLU. In brains, you can rather say you have like this recurrent system, and on top of it, like whenever like two signals meet, there's already a nonlinear thing happening to it. So it's much more complicated. Great. Good. Now that I did most LLM things, and I'll do a speed run in the end, let me start answering the non-LLM questions, and I'll just go by what's by the order of what's most upvoted. So here we have a question by Ian K, I guess. Given your recent brain and gradient descent talk, again, if Ian, if you know where the link is, if you could share it on chat, it might be interesting for some people. Do you have any favorite papers discussing biological plausibility and deep learning? Like, yes, as a matter of fact, I just co-wrote a Journal of Physiology paper together with Blake Richards, which is about the biological plausibility. In general, in that area, I highly recommend reading the work of Blake Richards, who has done a lot in that area. Walter Sen has written wonderful papers. there's a significant Joshua Benjo is interested very much in that area. So there's a big community. Jeff Hinton also has tried on biological backpropagation for a long time. So there's a big group there. Now, so let me go to the second question. Liquid neural network architectures inspired by the nervous system of living creatures called C. elegans, have been getting some traction recently into the general public. Do you have any thoughts on this work and its potential? So I'm not sure what's meant with liquid neural networks. There's like liquid state networks that were popular for a while. They were primarily popular in Europe, not worldwide. I viewed them as being very temporary because basically the idea there is instead of learning how neurons interact with one another, you basically set like evolution, how neurons are connected with one another, and you just learn the output, or you like just learn one piece of that. The advantage of that is it makes the system simpler, but it comes from a time where we were really bad at dealing with recurrent neural networks. Now we are very good at that. So kind of the problem that they were trying to address seems to have gone away over time. I'm not quite sure why there's still a field doing that. But yeah, like you can say for neuromorphic systems, for example, it makes sense that a field exists where you can say we haven't yet figured out how to train neuromorphic systems. Great. Next question. Here we have a question by Andreas Valantes, who asks, how well does a PhD translate to the health medtech industry? Is it necessary in the sense that it gives a candidate a competitive advantage, or is it better to get a relaxant master's and then enter the industry? I don't think I think about it like this. So a PhD, if it goes well, is a training in a certain type of thinking. If what your goal is primarily get a health medtech industry, then a PhD will add relatively little. No? Like they are happy to hire you. They want to see skills that are relevant. No? Like what will they, if you have strong computer science / data science background, can you show that without having a PhD? Absolutely. No, you can compete on Kaggle. You can take lots of courses. There's so many things that you can do in that space. By and large, companies as well as professors are kind of rational. They will hire people who are good at doing the things that they want done there. So that means that what you want is skills that are relevant to the health medtech industry. Does the ability to write a thesis translate very well into success in the medtech industry? No, like that's writing papers. Do you need to do some paper writing in industry? Like, yes, lots of bigger companies require you to push papers to make internal proposals and so forth. What a good PhD does, though, is it kind of enables you to be at the front of research and therefore do really cool, fun things that you couldn't be doing otherwise. If your goal is just make it into industry, you will probably do better by going to the industry, find out what jobs exist there, find out what skills they want, upping those skills and kind of moving up the ladder within industry. If you really enjoy working on research like prompts, you're probably going to have great fun doing that PhD. I should also mention the downsides. If you do a PhD, you will be paid much less. If you have a family, in some countries, it's almost impossible to live on it. You start making money later, you will generally be paid less than if you're in industry. So if money is a big issue, then you might want to leave for industry earlier. At the same time, if what you are into asking your own big questions, then industry is not so great because there's products that need to be developed, and then academia is great. So I think it's rather about soul searching. Who do you want to be? Who are you? And out of NeuroMatch, there's a lot of people in the deep learning as well as in the neuro course that go to industry early. There's lots of people who go and do academia. But there's one thing that I want to tell everyone. Choose to be in academia. if you want to. But because you take a big drop in the salary and you also take a big drop in freedom. Now, you can't choose. Like in academia, you can't choose so well which city you live in. So given what you pay for staying in academia, you should really demand on working on something that for you personally feels just like really awesome. So if it's not awesome, if it's not exciting, the set of questions, you probably will not be happy doing a PhD. There's a good number of people who did a PhD who like didn't enjoy it, who didn't feel that it was a good use of their time. So what I tell most people is that basically, if you want to do a PhD, that's kind of something only you can know. It's about like feeling, okay, like, look, I want to ask these questions. Like, I don't want to like build a product right now. And there's others who like, I want to build a product. I don't just want to ask questions. So there's that degree of freedom there. And I think, but if you stay in academia, if you want to do academia, then make it be awesome. And also, yes, so Milad has a follow-up question there. Can you do projects which are related to industry during PhD? Yes, so when I have people in my lab, like most people in my lab become professors, but I regularly have people who are going to industry. What I almost always do is I put them on a set of projects that prepare them for the industry where they want to be. What does that mean? You want to have like the right coding skill set. For a lot of people here at NeoMatch, it's going to be like a data science skill set. No, you want to be good with databases. You want to be good with large language models that you want to use for things. You want to be good at communicating. No? Like in industry, much more than in academia, it's about how you can be a good team player. You want to be good at empowering a team to get stuff done. And all those things you can absolutely practice during a PhD. And if during your PhD you're thinking of doing something like that, absolutely you should try and get prepared in that direction. I will next answer Julia's question. Julia asked, why have you decided to use hats to explain different types of models? Well, because hats are like physical objects that you can tie something to. I didn't have a better idea, and wearing a hat is like an expression, and so it's like it felt useful. 2, I've heard about your approach of getting positions by getting what the next paper would be. That is really impressive. Oh, what other not so evidence? So Julia refers to something that like the audience here cannot generally know. So there's 2 kind of generically different procedures with which you can apply to join a professor's lab. One of them is the I'm just the best kind of thing, where you're like, I was the best in my class and I was the best in my university and I spent 16 hours a day coding and so on and so forth. And I'm just like, great. And lots of professors are very happy to hire people with that background. If you want to really convince a professor to be excited about you, you want to basically write a short letter to them where you make clear that you care about them. Now, you don't want to be good at natural language processing. You want to be, oh, I'm really interested in creative objective function improvements in the context of LLMs. And here is why you'd be the best lab in the world for asking that set of questions. So this strategy of instead of becoming hireable by everyone, which means that you just compete on like an amorphous axis of being better, you want to specialize. You want to like, as if you want to apply to PhD students, you want to make it so that there's only 10 professors in the world who could hire you, but all of them will want to hire you. So you want to kind of really specialize. So Julia, based on that background, says, what others not so obvious strategies are that are the right thing? I mean, like, especially for not so extroverted people. Like, yes, it does help for networking to be extroverted, but the other one is being prepared. And that sounds like very generic. But let's say you get the chance to go to a university, to go to a workshop, or you go to a conference or something. These places will usually give you the list of who else is going to show up. Find the 5 people that really matter for you and really prepare for those meetings. And then you'll be able to impress the hell out of these 5 people, and hopefully they'll then be willing to hire you. And so I think preparation is another one. There's probably a lot more, but I can't I can't just pull them up. But great question, Ilya. Cool. So now we are running against the end of the hour. I don't want to run much over. So what I'll do from now, I'm gonna do what I call like a lightning round. I'll try to give you very quick answers here. What is the best way to start a career in the BCI industry if I have a master's in computer science, AI-related research, and some minor data science industry experience? I think applying is the best thing. Like there's no magic there. It's finding, like you want to kind of call everyone, contact everyone, ask people what they're doing, find out what positions are hardest for them to hire. You want to like tell them that you'll be solving the kind of problems that they absolutely hate, and then they love hiring you for it. So kind of, and oftentimes the way to get into something is be willing to kind of do the jobs that others don't want to do. What do you know, like data cleanup or something. Doing the applications for regulation and start there. But the best way to start a career is go to the BCI industry and start working there and asking them what they want. And like basically contact them, go to places where they present, show up at places where the CEO gives a talk, connect with the people there on LinkedIn, ask all your friends that have a job in the similar direction. Given that you're at NeoMatch, guess what? There's lots of NeoMatch and former NeoMatch people that are in the BCI industry, and a lot of them are really, really nice, and they will be very happy to help you. You just have to find them, and you have to be well prepared. Now, don't waste their time. Like if you contact them, say like, hey, this is what I want to do. This is how I think you could help me. Do you think you can help me with knowledge then? But great question, Ilya. Here we have a question of Ibrahim Tunk. In the first tutorial, we learned that for fixed average firing rate, the maximum Shannon entropy can be obtained when ISI distribution are exponential. Yet in the Steinmetz data, I also encountered neurons with uniform ISI distributions. That's great, where the mean ISI was substantially higher than other neurons. What could be the reason for that? Great question. Theories are timekeepers. Theories are solving special problems. Now, take, for example, something that controls my muscles. And I want to produce a very steady force. Do I want that thing to maximize information transmission? No, I want it to be like going like exactly at a fixed rate, perfectly making my muscle produce fixed activity. So yeah, there's like lots of problems. Information transmission is just one of them. Does the notion of maximizing Shannon entropy with exponential distributions only hold for a limited range of average firing rate? Well, in principle for all of them, but there are, of course, there's of course hard limits of the range of where we can be. Great question, Ibrahim. Here's a question by Ganendra. Have you used GPT for coming up with new scientific hypotheses with scientific evidence and references to build mathematical computational models or Python code? All of these pieces, but not of them taken together. Great question, Ganendra. Here we have another question by Ilya. Could you please recommend what parts of data science should we focus on to be good in BCI's decoding and analysis? You should be focusing on decoding and analysis, but above all, like you don't need to focus. You want to kind of be like reasonably full stack on the data science side, because guess what? If you join a BCI company, they also have a web page that needs to be optimized, and they have customers, and they have a pricing problem, and they have problems with like the people delivering things. BCI companies are kind of in everyone's face, so it's kind of not the perfect place to get hired, actually. But otherwise, just like get good at data science. Don't overthink the fitting there. Here we have a question by Joseph Dacour. I wanted to ask about the applications of manifolds to common neural research and music. And analyzing, yes, they are. Oh, this is a completely open box of manifold analysis. You will get exposed to it much more as you go down further into NeoMatch Academy. So I'd like to delay that for later. office hour. Please feel free to ask it again next time. Would you please give 3 examples of fMRI research, one each for what, how, and why models? Sure, there's models that just say, how can we, that ask, look, we can have a model that predicts brain activity, take brain score. That's just a what, there's nothing else there. There's why models, for example, when you fit Bayesian models to neural data, and there's how models where people believe they can figure out how the brain thinks by figuring out what each brain region does and inferring the errors between them from data. I'm personally very skeptical about that last part, but that's possible. Are there mostly what and how models? No, there's lots of Bayesian models. If you look for Bayes and fMRI, you will find lots of models that are going into the other direction. Great question, Gia. Here's a question by Andrea. Is there still a future for traditional machine learning algorithms, i.e. SVM, random forest, compared with deep learning? Absolutely. We, for example, use it to understand how deep learning works, but for most problems, it currently looks like deep learning approaches are right. Why deep learning is very powerful at kind of dealing with ugly domains that we don't properly understand. Here's a question by Arjun Ramaswamy, who asked, do you think consciousness is just a very large VLOOKUP table? No, I don't think so, and I wouldn't be the perfect person to answer that. Here we have another question by Ganendra. Jeff Hinton mentioned we require new components to build true AGI, and inspiration will come from neuroscience. I think Jeff has just changed his opinion over the last 6 months or so. Better algorithms than backpropagation is yet to be discovered. Despite bitter lessons of Sutton, there's hope for new ideas. There absolutely is hope for new ideas, and I am positive that we will do much better than current algorithms, even within a short period of time, like 5 years. Not so sure if neuroscience is going to be the path there. Here we have a question by Mohammad Amin. As your opinion, is there any way we could use closed loop systems to be personalized to individualized patients? Yes, we do a lot of things, and this is one of the big research areas in the current situation. Yes, there's high heterogeneity between patients. How can these systems adapt to changes in severity by basically closing the loop? Great question. I need to wrap up though. How probable do you think it is for companies to downsize substantial portions of their data science analysis teams in this decade due to the potential for one individual aimed by LLMs to outperform the current team and accomplish a faster pace? I don't think this will happen very much. Why? Because the things that are actually time intensive are always, how do you get the data? And then how do you take the insight you get from the data and put it into processes at the company? For that, you need data scientists. That's taking a lot of time, and LLMs can do absolutely nothing to convince your CEO to actually understand what you've been doing. Here we have a question by Nikolai Safonov. In academia, is there prejudice against a potential PhD student that has done a PhD but not defended? People will ask, why did you take all those classes, go almost all the way to your PhD, and then didn't defend it? There are lots of places where it's super understandable. There was a war in the country where I was, or I decided that I needed to do something else. But if you say I needed to do something else, people will be like, okay, let's see if that was a good idea. You're really set up for doing another one. That being said, by the time you do your second PhD, you'll be much better at doing certain things. It's unusual though, and there will be some amount of pushback and worries that people have. Thanks for the question, Nikolai. And a question by Andrea. What components in today's AI are still missing before it can reach AGI? Very briefly, I believe that systems that work well in a world that is evolving are the main problems, and systems that work well if there's very small amounts of data. A question by Chayanin Tongfasuk. Are LLMs potentially applied to the topic of deepfake detection? Absolutely, they will be used for it, and all kinds of other algorithms are being developed for it now. And the last question is a question by Rez. I'm a beginner and I'm learning a lot during the academy. How can I increase my chances of landing a job?